Math 2415, section 10.5, equations of lines and planes. In this video, we're going to do an example that has many parts to it, but all of them kind of tie together. Find the equation of the line passing through the points 619 and 903. Sorry, I was thinking area code. Through the points 619 and 903. Where does this line intersect the xy plane? Where does it intersect the xz plane? Where does it intersect the yz plane? And does this line contain the point 12, -1, 2? All right, to get started, in order to get any equation of a line, we need two pieces of information. We need a point the line goes through. We have two such points. But we also need a parallel vector. We call that parallel vector V. And as I mentioned in the previous video, oh, by the way, I invite you to pause the video and see if you can answer this on your own. Silly me. Or you can just watch me do it right now. Or if you pause the video and tried it, and now you're starting it again, let's see if we get the same answers. To find the vector V, all we have to do is subtract corresponding coordinates of the 2 points. And it doesn't matter what order we subtract them in. I typically do second point minus first point. So for the x coordinate, we would do 9 minus 6, x component. For the y component, we would do 0 minus 1. And for the z component, we would do 3 minus 9. So one possible parallel vector is 3, -1, -6. Now, to make the equation, we need to choose which point we want to use as our frame of reference. I typically use the first point. Either one would be acceptable. So we're going to take the line that is parallel, or we're going to find the equation of the line that is parallel to this and contains the point 619. Let's start with vector form. Vector form says that you take a generic vector x, y, z, and you set it equal to your parameter t as a scalar times the direction vector, which in this case is 3, -1, -6, and then add to that the vector corresponding to the point that you're going through, which would be the vector 619. That's a perfectly acceptable answer for vector form. For parametric form, and notice it didn't ask us which form, I'm just practicing all three of them. For parametric form, remember, we essentially combine the right side into a single vector and then equate components. In this case, x would equal 3t plus 6, y would equal -1t plus 1, so -t plus 1, and z would equal -6t plus 9. And if we needed symmetric form, on your homework and on your test, you'll be told which form to give. If we needed symmetric form, I mean, we have formulas for these, but the concept is you isolate t in each of these, and then you set all of those expressions equal to each other. If we solve the first equation for t, we would subtract 6 and then divide by 3, so x minus 6 over 3. If we solve the second equation for t, we would subtract 1 and then divide by -1. And if we solve the third equation for t, we would take z, subtract 9, and then divide by -6. But then again, the coordinates of the point are subtracted from x, y, and z. The components of the parallel vector are your denominators. All right, so we have the equations, but how do we answer these other questions with it? For example, where does this intersect the xy plane? Well, what must be true if you are on the xy plane? Z must be 0. Being on the xy plane implies that z equals 0. But how can we use that to actually locate the point? Well, let's think about it. We need to find the x and the y coordinates. And what do we know about the x and the y coordinates? Well, they're equal to this. But I can't figure out what these are unless I know what t equals. Well, in the third equation, I can solve for t because I know what z equals. So here's the train of thought. Z equals 0 implies that 0 equals -6t plus 9. Well, we can solve that for t. We could subtract 9 and divide by -6. That would give us -9 over -6. but that reduces to 2/3. So this implies t equals 2/3. But this implies two things, that x is equal to 3, I'm sorry, I said 2/3, but I wrote 3/2. 3/2 is correct. Continuing, if t is equal to 3/2, that implies that x is equal to 3 times t, or 3 times 3/2, plus 6, which is equal to 9/2 plus 6. 6 is 12/2. 9/2 and 12/2 is 21/2. But this also implies that y is equal to negative t, so negative 3/2 plus 1 from our second parametric equation, and that's equal to negative 1/2. And therefore the point on the yz plane is 21/2, negative 1/2, and 0, because we started with z equals 0. For the sake of time, I'm not going to calculate the other two, but I will tell you what their answers are. And I invite you to try to follow the same train of thought. You just start with a different variable equal to 0. For the xy plane, if you did the same song and dance, you would start with y equals 0. And then if you did all of your chain of implications, eventually you would draw the conclusion, oh, wait a second, this is a point where y equals 0. You should end up with 3, 9, 0, 3. I strongly recommend, though, that you follow the same train of thought that we did on this one and arrive at this point. For the yz plane, if you're on the yz plane, then your x is equal to 0. And if you push this all the way to its conclusion, I know the x would be 0. Give me 1 second to think this out. I'm going to talk it out loud. If x was 0, then t would be negative 2. And if t was negative 2, then y would be 3. And z would be 21. I'm pretty confident that's correct. You might want to check it. All right, so we have one more question. Does this line contain the point 12, negative 1, 2? If you have the equation or equations of a line, there's a straightforward way to see if a point belongs on the line. Namely, is there a value of the parameter, a unique value of the parameter that generates that point, that order triple? To answer that question and possibly locate that parameter, just pick one of the coordinates and see what its t has to be. Let's start with the x. If the x is equal to 12, that implies that 3t plus 6 is equal to 12. And if you solve this, this implies t equals 2. But will t equals 2 give us the correct y coordinate and z coordinate? T equals 2 implies that y is equal to negative 2 plus 1, which is negative 1. That's the correct y coordinate. But this also implies that z is equal to negative 6 times 2 plus 9. But negative 6 times 2 is negative 12. Negative 12 plus 9 is negative 3, and that's the wrong z coordinate. So, therefore, the answer is no. And again, it's actually just a game of, is there one parameter that generates all three coordinates simultaneously? So you find the parameter that generates one of them, and in this case, the parameter that generated 12, that was t equals 2. Then you see if that parameter produces the other two coordinates correctly. If it does, then yes, the point is on the line. Otherwise, it's not.